we want to write each of the following in log form. So what that means is we're going to use that property where we go back and forth from exponents to log. Okay, so focus on your base first of all. So I know right away it's going to be log of 3. Over here, it's 81, so I know it's going to be log of 81. Now it's going to equal something, and I just think, okay, what I'm taking the log of is what this thing was what the exponent equals. So it's going to be log of 1/9. Here, what I'm taking the log of is what this whole exponential part has to equal, which is 27. Now these exponents are what the log equals, which is 3/4. Okay, so let's check. 3 to the negative 2 is 1/9. 81 to the 3/4 is 27, and it all checks out. So start with your base, make that your base of your log. What your exponent equals is what you're taking the log of. What your exponent part equals is what you're taking the log of. And then your exponent over here is what the log equals. Okay, and a lot of that's just getting practice. I know it gets a little confusing, but just gets practice. Okay, example 8. If log of 3, I can replace all of log of 3 with 0.5. I can replace anytime I see the word log 4 with 0.6. We want to take that pieces of information and kind of analyze the following. Okay, I'm taking the log of a fraction, right? And we have this property that says if I take the log of a fraction, I can divide it up as the log of the top minus the log of the bottom. If that was 3 times 4, it'd be log of 3 plus log of 4. But within a fraction, we just take log of 3 minus log of 4. Well, log of 3 is 0.5. Log of 4 is 0.6. So all this together then would be a negative 0.1. And there's the answer for that one. As I go over here to the next one, it's a little more trickier because it's like, oh, it's 48. What we've got to want to do is we want to factor 48 into like 3's and 4's. Because I need it to say log of 3's and 4's, not just 48. So let's think about it. 48. That is, I know that is 16 times, let's see, 16, it's 16 times 3. Well, that's good because it gives us a 3. And then I know 16 is obviously, if I'm going to write 16 as either 4's and 3's, it's going to be 4 squared. Okay, so log of 48, let's start there. Log of 48 is the same thing as the log, and I'll put this in parentheses, of 4 squared times 3. Okay, now like I said before, log of a product, you break it up. If you want to take individual logs, you break it up by adding each of the pieces. And anytime you have an exponent, remember what we can do with that? We can pull it to the front. So it's 2 log 4 plus log of 3. Let's take our information. I know log of 4 is 0.6, so it's saying 2 times 0.6, and log of 3 is 0.5. So cleaning this up, 2 times 0.6 is 1.2, plus 0.5 would be 1.7, and there's the answer for that one. Okay, so example 9, what we want to do here is we want to write 2 times the natural log of A plus 3 times the natural log of B all as one log. Okay, so what that means is combine it all together, and we want to write it just log of this, or in this case natural log of just this thing right here. Okay, first things first is look for coefficients. If you see any numbers in front, put them back as exponents. So this is the same thing as saying natural log of A squared plus the natural log of B cubed. Always, always, always do that first. Okay, and now you just check, do we have the same kind? Yes, it's both natural log and natural log. So now I'm going to write one of them, and here we go. If your term is positive, you're always going to be multiplying. So it's a positive and a positive, so we're going to be multiplying A squared and B cubed. And there's the answer. Simple as that. Okay, so let's go to the next one. This time I have 3 of them. Always start with the first thing I said over there. Go to the front. If there's anything in front, put it as an exponent. Okay, well, we don't really have one for that guy. For this one, it'll be the natural log of x plus 1 to the 1/2, and then minus the natural log of 1 plus the square root of x squared. Okay, Keeping on with this, we natural log, natural log, natural log, all the same. So I'm going to write one big natural log, and notice here, I have a positive front term, a positive second term, but a negative third term. All right, when you have a group of them, just start out just like this. Okay, just give yourself a big fraction in there. If what you go to each individual term, if it's positive, then what you're taking the natural log of is going to go to the top of the fraction. So the natural log of 2, it was positive out front, so the 2 is going to go to the top. Okay, the second term right here, it was positive. So what I'm taking the natural log of is going to go to the top, and you just keep multiplying it in. Okay. Now this third one, because it's negative, then what you're taking the natural log of back here is going to go to the bottom. So 1 plus the square root of x, all of that squared. Okay. And just to say, just for kicks, if I had a fourth term, let me put that in there as a different color. If I had a fourth term that said, then again, minus the natural log of 3, because this last term is negative, that means that that 3 has to go to the bottom, and I would just multiply it into the denominator, just like that. Okay? It's the easiest way to kind of remember the whole, when does it go top, when does it go to the bottom, how do I work that? Is just go term by term by term. Take away the natural log part. If it was positive, put it at the top. Take it away. Positive, put this in the top. Negative, put that in the bottom. Negative, put that in the bottom. It's just as simple as that. And as you throw terms in, just keep multiplying them together. Okay, example 11. I just want to simplify the log of, and it looks like we've got a big product in here. It's x times x squared plus 1 to the negative 1/2. Okay, so I've taken the log of a product. I can break it up into the log of the first thing in the product plus the log of the second thing in the product. Okay, from there, log of x is not much I can do with that, so it's going to stay log of x. I can take this exponent though and chunk it down front. So instead of saying a plus a minus 1/2, let's just go minus 1/2 log of x squared plus 1. And that right there is all that I can possibly do. So that would be the answer for that one. Because remember, let me tell you give you kind of the what ifs. I only have rules for when I'm taking the log of products and logs of quotients, like x over y. When you have a log of a sum, you can't do anything. It's got to stay just like that, okay? There's no rule for log of sums. It's like me asking you to combine x squared plus x cubed. Well, they have the same base. Well, great. But because the exponents are different, they're not like terms. Same thing happens here. It's like, okay, they're kind of there, but you can't really do anything. You can only have formulas for logs of products and logs of quotients, and that's it. Okay, so let's go to example 12. I want to simplify the natural log of x times e to the negative x squared. All right, so I've got a product. Let's break it with addition. So the natural log of the first thing in the product plus the natural log of the second thing in the product. Okay. All right, well now my first term's done. It's just the natural log of x. Can't really do much there. But let's look really, really closely at this one. With natural log, we never write the base because the base is always the same. Natural log can only have one type of base. It's actually base e. So every time I see these, there's actually technically a base e there. We just never write it because it can't be anything else. So if it's got to be e every single time, then don't worry about writing it. But remember, we have that property where if your base here of your natural log or your base of your log is the same thing as your base of what you're taking the natural log of, those cancel, take that log with it, and you just get the exponent. Okay? So that second term cancels to just a minus x squared, and that's it. Okay? So that's using that whole property that says, you know, if I had, let's say, even log base 4 of 4 squared, those are the same, takes a log with it, and you just get 2. If I had log of 10 cubed, well, technically the base of the log's not written, so it's understood to be 10. Those can't match up with each other, it takes the log with it, and it's just going to be 3. That's that property we're using right there.